All right, so today I'm going to talk about advanced threat hunting. So the process that I'm going to describe here today is one that my team has been working on and kind of tweaking and improving and also failing and learning by our failures for the past about 3 years, since late 2014. And so what I want to do is give you an idea of how to implement this process on your own. And then, if you can use it in your organization or if you want to use it on your own, please be my guest. But the process is to hunt for unknown malware, unknown threats, and organize them in a way that makes sense and can allow a smaller team to tackle a problem where there's a lot of data to look through and a lot of data to sift through and to understand. And so this process kind of narrows the noise and the amount of data down to something that's manageable for a small team to analyze and to perform research on. So first of all, who am I? I am the Director of Research Innovation at Threat Connect. The research team is my team, and when I started in 2014 there, I think I was research team member number 3, and now we have 9 people on the team. And again, this is the whole process here, and some of the stuff that I'm going to try to convey to you this is usable by a small team. We're not like a giant AV company with lots of researchers, et cetera, et cetera. We're a very small team. So before I dive into the process and talk about that, I want to get a little bit of a few definitions laid down. So this is going to be the sort of the few school slides before we get into the fun stuff. So when you're talking about threat intelligence, malware analysis, and investigating and researching malware and threats, it comes in a couple of different types and sort of flavors. So you have tactical intelligence, and this is where you're looking at the tactics and the techniques and understanding the behavior of the adversary and what sort of techniques they put together for an attack. And then you have technical intelligence. So this is looking at specific indicators of compromise that pertain to a particular piece of malware or a malware family. So this can include, network indicators, IP addresses, host names, URLs, user agents, anything that you can use to differentiate one malware family from a different one and understand, perhaps what it's related to and who wrote it, ultimately. And then you have operational intelligence. So this is intelligence that you can use to make decisions. And you would actually boil intelligence down to something that you can use in a process. So this is basically designing processes and designing the operations of an intelligence process. So the last one is strategic intelligence. So this is being able to provide intelligence that allows people to make decisions. So if you have, if you have a decision to make, perhaps there's been an incident that needs to be responded to, and you have an IR team responding to an incident, and then if you don't have strategic intelligence available, you might not be able to make a decision as to how to proceed in the incident response. But if you have good strategic intelligence, you can make a better decision there. So today, this process, I'm going to drill down into technical intelligence, so specifically technical. I know this is a slide from the government, so it's like a terrible font and really ugly, but it at least conveys the intelligence process. So What we're going to be talking about today is collection. So you have your operating environment, and this is your network. It also is the rest of the internet. It is websites, anything that you can collect data from, open source intelligence, packet capture from your own network, logs, this sort of thing. So you have collection. And then processing and exploitation. This is also the next step that I will be talking about today. So this is where you take the massive amount of data and then you turn that into information that you can then analyze. And then obviously the next one is analysis and production. So this is where you have an analyst looking through all of the data that you've been capturing and then exploiting and organizing for them. So, and then dissemination, that's basically writing a report and handing it to your boss. So this is a different way to look at the intelligence process. It's the same process, but a different way to look at it. And this is how, what I'm going to talk about today is a way to kind of reduce the amount of data down to something that is usable. So again, you have your operational environment, and then the collection process, you're gathering malware samples, you're gathering PCAP, you're carving files from PCAP. So that's your collection process, and now you have a big pile of data. But when you have a big pile of data, you can't just sit there and sift through all of it manually. You need to have automation, and so automated sandboxing, and then also investigation before you get to looking at a file. You use a system called Yara. Is anyone familiar with Yara? Awesome. Couple of hands. All right, so I'll go into some detail in a moment about what Yara is, but it's essentially a signature-based system for classifying files. So you pass a file through Yara, and then it will either match on one of the rules, or it will not match on the rule. And so if it matches the rule, if you've written your rule well, and it's fairly specific, then you can determine that this is a specific malware family or a particular attack type. So then you've applied all of these processes, and now you have information, and then you add people into the mix, and then you produce intelligence. So, and this is, I promise, this is the last sort of educational slide before we get into the fun stuff. So David Bianco, who is a threat intelligence expert, this is the pyramid of pain. And so the pyramid of pain, this is the different data types and concepts that you can research when looking at a threat or a malware family. And the ones down at the bottom are the easiest for an analyst to discover. So this is like taking a malware sample and getting the file hash, or perhaps taking a malware sample and looking for the import hash or the SSD hash, looking at the specific hash values of a sample. So this is trivial, very, very easy to do. And also, from the adversary's perspective, the person who wrote the malware, this is the least annoying thing that you can do, because all they have to do is change the malware slightly, and it'll have a totally different hash. And so the hash values that you have before are no longer going to find that particular sample. Easy, you've got IP addresses, so you run malware through a sandbox, and you get C2 command and control callbacks like IP address, domain names, network artifacts. So those are in the middle area, easy, simple, slightly more annoying for network and host artifact. And the more challenging is tools, so understanding what the tools are that the adversary uses and being able to detect the tools that they're using to attack you. And then the last one, the most difficult for network defenders to find and determine is a TTP. I hate the term TTP because it comes from military and jargon. So what we should just call it is it's an attack pattern. It's the pattern that an adversary uses when they're attacking your network. It's a little bit easier than TTP. It's like, what is TTP? What does that even mean? So what I want to do is kind of highlight that if you have the pyramid of pain of where you are basically causing trouble for the adversary, taking his tools away from him, removing attacks from a network, stopping attacks. So from that way, the most difficult thing for a defender to do is to discover the TTP, but in the mirrored pyramid of pain, there's sort of to find a TTP, you have to create a process for looking at threats and malware. So in that same way as discovering a TTP and taking that away from the adversary, developing a tested process for finding malware and analyzing it is just as important and also just as dangerous for the adversary. So if I can share this process that I'm about to tell you, you can use it. You'll make a lot of problems for the malware authors that you're going against. So we come back to the problem definition. So what are the problems that I'm trying to solve here? So this one is the main problem is that we have a small team. We don't have unlimited numbers of people that we can hire. There's a certain budget that we have, and you can only hire the number of people that you can, that you're allowed to. So in my example here, my team is 9 people. These are our little, kind of icons. And you also have limited resources. So you're operating in the middle of a desert, searching for water, and at the same time trying to analyze malware. So you have, of course, you have paid data feeds. There's all sorts of companies out there that are trying to sell you a feed of information, data. Those cost money, so you have to use them sparingly. And then also you have a huge data volume. I mean, it's the number of malware samples. If you look at the number of malware samples that are submitted each day to VirusTotal, it's absurd, just the number of files that they process each day. So you have a large data volume that you have to look through. And then you also have signal to noise, because if you don't tune your process very well, you're going to get a lot of false positives. You're going to get a lot of garbage, and that's going to kind of clog up the system. And then you have limited tool capacity, because let's say you have an automated malware analysis lab or sandbox for sandboxing malware, it's a limited resource. There aren't unlimited numbers of VMs. There's a certain number of VMs and a certain number of time in the day, and so that's a limited resource. So you need to you need to be aware of the different limitations that you have. And then also you have limited time. So analysts are people, and analysts need to spend time analyzing data and analyzing malware, not uploading something and waiting for it to do this and then finding this over here, moving data around, which I kind of equate to picking up a box and then putting the box in another room and then picking up a box. It's a terrible process to put your analysts through, because you can always automate much of this. So I hope this comes. It actually came through very well. All right, so this is the process that my team was using when I arrived at my company. So as you can see, there's a lot of activity on the analyst side, and there's not a lot of things that are happening over on the system side, right? So my goal was to reshape the process and automate as many of these steps as possible, to move things over to automation, move the boring wastes of time over to servers, instead of having the analyst's time wasted that way. So what I want to describe over here, so this is the Yara, using Yara rules to hunt for files. The files can come from wherever. You may have a mail server that you're collecting attachments from. You might be carving files off of your network. You might be downloading files, collecting them on the internet, just from different sites. And all of these files you basically pull together in one place. And so the first thing that your analysts are doing are taking files and comparing them. And I think it'll be a little bit more illustrative in a moment when I show you exactly how Yara works. But basically, you're comparing different files and you're trying to figure out what is a commonality among those files, and then writing a rule that can find that commonality. And then in the future, when you pile these, thousands or hundreds of thousands of files on top of your Yara system, it will find that, it'll find new versions and, new builds of that same strain of malware or that same type of file. So here, and this is the bad process, we've had the analysts sitting there manually writing the rules, keeping them in text files on their laptops, and then cutting and pasting to deploy them, So yeah, I know, come on. It's only good if you have something to fix, right? So then the rules get deployed, and then you get email notifications or whatever sort of notifications you get back from your Yara system, and you have to read through the notifications and go, is this one important or is this one important? Why is this important? And then you download the files. You maybe send them to a sandbox. So that's going to be this this process over here. So you upload the files to the sandbox, and then you sit and wait. Pour yourself some coffee. The malware runs for a certain number of minutes, whatever you set it to, and then hopefully it will call back to its mothership, and you'll get network indicators from the sandbox session. So then you have a report from the sandbox, and you have to copy information from that and put it all together into an overarching report about that particular piece of malware. So all of that is highly manual. So what I've done is take as much of it as possible and automate it. So and this seems obvious once you've begun working with it, but Yara rules look like source code, so treat them like source code. Put them all into a Git repository, so you keep them nicely organized, and you can see. I love the button on GitHub called Blame. You can hit the blame button, and you can see who it was that made the mistake and what line that mistake was made. So you can see what's happening, and you can organize across a team. So keep all of your Yara rules and signatures in general in Git repositories. So, and then my team, we do the Yara hunting mainly at VirusTotal, but the source of files that you have can be anything. If you're a network defender, it's probably going to be the system that you would be building would be looking at files that are in your organization, as I said before. But and this is the really cool part that I'll get into in a moment. So the notification prioritization. So that's like the prioritization is the core of the process that I'm talking about here, and we'll go into detail there. But the other part is just taking the file, uploading it automatically to the sandbox, and then having all of that information, the report from Yara, the notification from Yara, and then the report from the sandbox, all of this put together in one place and then organized in a priority. So organized into a queue that an analyst can look at from the top and just take stuff that's the most important. So Yara, like I said before, there were a couple hands of people that know what Yara is, but basically Yara, and this is taken right from Yara's website. It's open source. It's available on every operating system you could imagine. So Yara is a tool aimed at, but not limited to, helping malware researchers identify and classify malware samples. So classification is the really key part about of how I'm using Yara in this particular process. So this is a Yara rule. It looks just like I said earlier. It looks like source code. Yara actually compiles the rule before it applies the rule to the files that you're looking at. And so you'll notice, if you're familiar with Yara rules, there's a couple of there's some extra stuff that I've added up at the top. So the meta section. The meta section is not actually compiled or looked at by Yara. This is just an area where you can put kind of notes or other data points. So what we've done is added a few data points here. So priority and confidence. Priority is, for our team, this particular strain of malware, how important is it for us to look at this and how quickly should we look at it? Confidence. So this is, initially, the analysts that wrote this rule, it's their gut feeling as to how correct they were and whether this is going to be, a productive rule, whether, the Nemocod ransomware, JavaScript ransomware here, this confidence is high because the analyst is really very sure that if this triggers on a file, then it actually is Nemocod. It is the Nemocod JavaScript ransomware. And then down, there's also this sandbox restricted. So we've added this, which certain files, if you find them on your network, are not necessarily files that you want to waste cycles sending them automatically to the sandbox. You could be looking for things that won't actually run in your sandbox, but it's still important to catch them in your collections. So if you know that the file either shouldn't run in a sandbox or it won't run in the sandbox or you don't need to run it in the sandbox, I've added this flag here so that these rules can be still prioritized correctly, but they won't waste time in the sandbox, in the automated malware analysis system. So coming back to this, the notification prioritization, that's this right here. Oh, that didn't work. Sorry. I was going to magnify, but it looks like my mouse won't go over to that screen. But the notification prioritization system is like the core. And like I said, my team, and I hope that you can learn from us, we were doing it wrong. So when I first began and looking at the process that we were using, we were doing it incorrectly. So you don't want to keep your YAR rules, don't keep them on a file server, you don't want to keep it on some guy's laptop, and you definitely don't want to spread it out over everybody's laptops. So you want to have it centralized in Git repository. If you like Subversion, it doesn't matter. It doesn't matter what sort of revision control system you use, but use a revision control system. Oh, there's an extra slide in there, sorry. All right, so in the distribution of YAR rules come in two basic flavors, let's say. So YAR rules can be deployed out at VirusTotal. YAR itself is actually an open source project maintained by one of the people that works at VirusTotal. But you can also deploy them, on your own on a server running Yara or on your laptop running Yara. And so the vocabulary, the syntax that's used in these two rules are slightly different. So if you have a rule that works, that has the syntax for VirusTotal, it actually won't compile on the open source version of Yara. So therein lies another problem. Once you've got a library of signatures, you then need to have a way to automatically deploy them in two different directions. So what I did was I was looking for a way that I can parse the YAR rules in an automated way, and so I looked around. I know everybody's probably used, if you use Yara, you probably use Yara Python. Yara Python is awesome. It does, oh no, LastPass, go away. So it does compile the rules and it lets you look at all the different components, but Yara Python can't compile the ones that you deploy out at VirusTotal. So I needed to go find a different tool. So I started perusing the internet and I found an open source project that had been a little bit abandoned. It was rough around the edges, and it is called Ply Yara, PL Yara. So it's based on Ply, which is Python Lex Yak. I know I might be speaking French or German now to some of you, but Lex and Yak are two very old Unix commands. So if you have a Unix box, Linux, you can type Lex and Yak, and they work together. What Lex does is it takes basically it takes some rules that you write for it in code, and it uses regexes to find tokens. So it basically tokenizes a set of text. And so the YAR rule, what it does is it looks for each one of the different pieces of a YAR rule, each word and each symbol that's part of a YAR rule, and it basically Yak, which is the second part of this process, Yak knows the grammar of the rule. So Yak basically asks Lex, like, cough up a token. So it's like, all right, here's the next token. And so Yak goes, all right, I understand this token fits in the YAR rule in this position, and in this position, and this position. So what you basically are doing is you're writing a parser. So it's basically a parser to parse the YAR rule into all the different component parts, and then spit out a JSON, spit out either a JSON or spit out a Python dictionary so that you can access each one of the different pieces in the YAR rule. So we're going to look at that. And by the way, the original author hasn't merged all of my updates to Plyara. So this one, if you want to go use it for yourself, use mine until they merge all the changes. I basically rewrote it from bottom to top and fixed a lot of problems. But let's take a look at what it does. All right, so I hope you can see that. I think the magnification is not going to work. All right, so I'm basically reading in the YAR rule file. This one is POS, so this is a set of point-of-sale malware rules. Ooh, what happened? I'm zooming in. Oh, you're zooming in. All right, thank you. All right, so perfect. All right, so now I'm parsing it using PL Yara. You can see that there are eight rules, and this I've taken the rules and converted into the dictionary, and now I'm dumping them as JSON so that you can read it easily. And if you want to scroll down a little bit to the 23rd, yeah. So as you can see, it takes the YAR rule and it breaks it into component parts. So this section is the conditions, the condition terms. Scroll down a little bit further. Oh, I have to scroll. All right, cool. It's my turn. All right, so as you can see, this pulls out the confidence and the priority, so I can use them very easily in automation. So now those are variables that I can use very easily for my prioritization system. And this one, the one that you're looking at right now is Alina POS, which we're going to come back to towards the end. I've got a pretty interesting thing to show you at the end. So let me get back out of this. Can you unzoom? Awesome. All right, so back here. And by the way, I'm going to give a little shameless plug for the software that you just saw me use. So that's it's Jupyter. If anybody uses Python, honestly, using Jupyter and notebook programming, this is the way to go. This is the way to really streamline your development process. So it's open source. It is the new name for IPython Notebook, if you're familiar with that. So this is the ultimate. This is just a little bit of JavaScript that my team whipped together for displaying the prioritized notification. So each one of these represents a malware file that was triaged by Yara. Sandbox potentially, and then prioritize. So we can, basically order them in priority. If you don't want to write something in or you don't feel like working like to this depth or anything like that, just put it in a spreadsheet, and then you can order the columns by your priority and confidence. So now you've got now you have a work queue where you can have a set of analysts and they can pick off the stuff from the top, which is going to be the most important for your team. So one of the things also here I wanted to show you is over time I've found that you need to order them in groups that are actually slightly less intuitive than you would think. So it's not just ordering it in high priority, high confidence on down. Notice the bottom part. So the stuff that's basically noise, all the stuff that's low confidence, put all of that at the very bottom. Even if it's high priority, if it's low confidence, it's going to be a lot of false positive. It's still going to waste your time. So it's not really intuitive, but over time I've learned that this is a really good order for the priority and confidence. Again, we're going to go back to something that is kind of the boring thing and annoying. So you have to have meetings. So you have to meet as a team and you go over the different malware families that you're looking at. What are the things that are important for your team? So you have to make these decisions and then go down all of the different malware files, YAR rules, and adjust your priority as time goes on. So I don't always show up to meetings, but when I do, I derail them with stupid questions. So another thing that this will do when you've got when you have your entire process nice and efficient, you can make your bean counters and the people that make your budget, you can make them happy, because if you maintain this process and you take metrics on your entire process, you can demonstrate that you're using your resources at their maximum level. And so if you can demonstrate with numbers that you're using your resources at the maximum level, you can then go to the people that control the money and say, hey, I need more money because I'm using the money that you're giving me as efficiently as possible, and I can show that I'm doing that. So you can make your bean counters happy. And so this is kind of going to wrap up the talk, but I want to show you some of the success stories that my team has had recently. And so Marika, one of the team members, this is this is a blog post. Please go check it out. There's all sorts of really interesting stuff there. But this was a piece of malware that we picked up in our collections. And it was targeting it used decoy Palestinian Authority documents, and I'll show you what one of them looks like. So a lot of malware will have decoys that kind of convince you that this is something interesting that you want to look at, right? And then all of a sudden, it's not actually what it said it was, and you're infected, and you're calling back to a C2, and your email is on WikiLeaks, or I don't know. But so this is the bait document for this particular strain of malware called Casper Agent. And so this was something that we looked at and found, quite an extensive, attack beyond what was known at the time, in the media. And so please take a look at this. There's much more information on that blog post than I can really go into depth here, but please do a little homework and read the blog. And now the next one I'm going to talk about, this is the last thing I'm going to go over. But this is something that I've been using the process that we discussed here, the malware and threat hunting system. I've been chasing one particular adversary for about 3 years, 2 or 3 years. So when I first found this person, they are the author of Alina, at least one build of Alina point of sale malware, Alina POS. And this person was using one particular email address to register the command and control domains, and it was z556677 at hotmail.com. Trust me, I've been chasing this person for years. I know, I have all of their information in my head. But what you're looking at here, this is what's called a graph. So this is I built this using Maltego, and it's where you take all of the information, this sort of jumble of information that you're collecting from all these different places, and you can organize it in relationships between different data points. So you can take the particular piece of malware, and then you can relate that to the IP address or the domain name that it calls back to. You can look in the WHOIS information in that domain name, and you can find Z556677. You can then pivot from that and find other domain names that the same adversary has registered. And then eventually, after years of almost looking like this, you find, what's that? Yeah, this is Charlie from It's Always Sunny in Philadelphia, by the way. This is a great show. But after you collect information on this particular adversary, and you have more information and more information, I finally found that they used a particular Twitter handle, and they slipped up. Everybody has bad operational security. Everybody makes a mistake somewhere. So what I did was I took the Twitter handle that this person was using, and then bounced that across all of the different password dumps that I had access to. So this guy used MySpace back in the day, and so the MySpace dump from years ago had a slight variation, a subset of the characters for his Twitter handle that he uses now in his password in his real MySpace account, with photographs and friends and all this sort of thing. So if you're a malware author, make sure that you don't slip up. But and if you're a defender, just keep at it. Keep on building your graph and getting a little bit crazy, but eventually you will find someone. You'll figure out exactly who they are, hopefully. So I hope you've enjoyed this, and I hope you'll be able to use this process if you're doing network defense. Thank you so much. And if you have any questions?
What happened with the malware author? You gave the information to the government? Or?
Yes. Yeah. So and that's the thing. When you report something like that to the government, it's sort of like a black hole. They don't tell you, oh yeah, they don't tell you what happened, but Any other questions?
So in the end, still being there payoff. So if you're still acting it and still collecting information, payoffs.
Well, I haven't seen much activity from this particular adversary in a while, so maybe something worked. All right, thank you everybody. Thank you very much.